Good day, everyone. Welcome once again to our session. So today we're going to continue our discussion on the integration by partial fractions. So I have given you already two examples. So this time I'll give you the third example. But before that, I'd like to point out something which I forgot to mention earlier. Okay, so we have this concept class now. We have discussed this before. These are the basic rules that we need to follow when we deal with partial fractions. When our integrand is composed of fractions that can be dealt with integration by partial fractions. So we have here different possibilities. Three different scenarios class where we can have distinct linear factors, for example something like this, okay, or we can have repeated linear factors. We have here an example something like this, or we have quadratic factors, okay, something like this. So as what you have noticed class, in this given in this third scenario, quadratic factors, you see that the degree in the numerator is less than the degree at the denominator, and similar to this one. So the degree here at the numerator is less than the degree at the denominator, and so do with this, okay, and also with the okay. So we have here the distinct linear factors. If you look at the degree at the numerator, it's less than the degree in the denominator, okay, and also in the repeated linear factors, you see that the degree at the numerator is less than the degree at the denominator, and so do with these quadratic factors, okay. So in our previous two examples, we're dealing with scenarios where the degree in the numerator is less than the degree at the denominator. So this time I'm going to show you the solution of the scenario where the degree at the numerator is equal to the degree at the denominator. And in our future example, in our next video, we'll deal with degree at the numerator is greater than the degree in at the denominator, okay. So let's continue with our example. So this time this is our next example class. Our next example, we have here again the instruction here is to integrate this given integral of, at the numerator we have x squared minus 1, and the denominator is x squared minus 16 times dx. Okay, so as you have seen, the degree at the numerator, so you have here the degree at the numerator is equal to 2, and the degree at the denominator is also equal to 2. So the degrees in the numerator and denominator are equal. Okay, so how will we solve this problem? So to solve this problem class, we need to do the division or the polynomial division first before we proceed as what we have done in our previous two examples. Okay, so when you divide or when you do the polynomial division, so we will obtain, so what shall we obtain after our polynomial division? So this can be written as, this is just equivalent to the integral of 1 plus so let's put it inside the parentheses, 1 plus 15 divided by x squared minus 16 and multiplied by dx. If you're wondering where this expression is coming from, as I mentioned, we have to do the polynomial division first. So how to do the polynomial division? Okay, I'll show you it here. We have here we have the numerator x squared minus 1 divided by x squared minus 16. So we can rewrite this using the polynomial division. We can do like this, x squared minus 1, then divide this by x squared minus 16. Okay, and then when you look at the degree, they are just the same. Okay, and then this is x squared, we have x squared here, so we can have 1 here, 1 then multiplied by this divisor, so we have x squared minus 16. And we know that from the rule of division in polynomials, so after you get this number here, you multiplied it by this divisor, okay, and this is the result. And then the process here is that you have to subtract, no? You have to subtract this expression here by this expression. So you have to subtract. So when you subtract this, so it means that the sign here becomes positive, okay? And we have here x squared minus x squared is 0, then minus this is plus, so this is plus 15. So that's why we have here 15. So the 15 here is the result, here is the remainder, okay? So remainder, of course, the remainder is to be divided by the divisor. That's why you have here. So after the long division or the polynomial division, we have this expression. So this integral is equivalent to this, okay? And then let's proceed to the steps that we've done similar to our first two examples. All right, so we can write this now. We can rewrite this as the integral of 1 plus a over, before that one we have to, okay, so we have to factor first this, after what we've done a while ago, this one. The next step is to factor the denominator of the second term. So we have 15. So this is the integral of 1 plus 15 divided by, so the factors in the denominator are x plus 4 and x minus 4, okay? Then multiplied by dx. I'll just erase this so that we can have space. Then times dx. Then after that, let's proceed with decomposition. We have to decompose into partial fractions for this part. So we can rewrite this now as the integral of 1 plus, we have a divided by x plus 4, then plus b divided by x minus 4, then everything is multiplied by dx. All right, okay, so what shall we do next? We can just deal with this part in the way that we have dealt it with in our previous examples. We can leave this one here because we can integrate 1, integral of 1 times dx is just equal to x. So we have to deal with this part only. Okay? And then we'll just combine them together later on. So taking this part, we have here, since we are going to consider this part, it means that we have to deal with this only. So we have 15 divided by x squared minus 16 equal to a divided by x plus 4 and plus b divided by x minus 4. Then finding the LCD on the right side, so we have x plus 4 times x minus 4. Then LCD divided by this, so what is left is x minus 4. Okay, then multiplied by a, so we have a times x minus 4, then plus, this is plus, so this is also plus, so this LCD divided by this denominator, so what is left is x plus 4, then multiplied by b, so we have b times x plus 4. Okay, then equating the numerators, so when we equate the numerators, so we have 15 equal to a times x minus 4, then plus b times x plus 4. And again, so the value of our x to be substituted in this equation is the result when you equate these factors to 0. Okay, so equating these factors to 0, so we have x plus 4 times x minus 4 equal to 0. So we have therefore x plus 4 equal to 0, x minus 4 equal to 0. So therefore we have here x equal to minus 4. The other one is x equal to positive 4. So these are the values of x that we are going to substitute in this equation, okay, so that we can solve for a and b. Then once we solve for a and b already, we have to substitute it into this equation, okay, and then solve our integral. Alright, so to continue, I will use another board. Okay, so I have here another writing board. So I'll just rewrite the resulting equation, which is 15. Okay, so we have here 15 equal to a times x minus 4 plus b times x plus 4. Alright, so when x is equal to 4, positive 4, when x is equal to I'll start with negative 4, from the two factors that we've got here. Okay, so we'll use these values for x. So when x equal to minus 4, so substitute this here in this equation. So we have 15. Okay, so 15 equal to a times x equal to minus 4, then plus b, x equal to minus 4, and plus 4. Okay, so this part here, this part is minus 4 plus 4 is equal to 0. So that becomes 0. So what is left here is 15 equal to negative 8a. And then from here we can solve for RA. So RA here, from here we have a is equal to divide by minus 8 both sides. So we have minus 15 over 8. So this is our A. Okay. Now when x equal to, I'll write it here. When x is equal to positive 4. Alright, so we have substituting into the given equation or the resulting equation. So we have 15 equal to a times x equal to 4. So this is 4 minus 4, then plus we have b times 4 plus 4. So 15 equal to, so again this part here, 4 minus 4 is 0 times a, so the whole thing here is equal to 0. So we have 15 equal to 8b. So from here we can solve for b. So our b here is equal to 15 over 8. Alright, so substituting these values for a and b in our equation. So we have our equation, our integral, which is I just rewrite it here, class. So we are given initially as integral of x squared minus 1 divided by x squared minus 16 times dx, which after our polynomial division, so we got the integral of 1 plus 15 divided by x squared minus 16, and the whole thing is multiplied by dx. Okay, this times dx, then equal to, so we rewrote this as integral of 1 plus a divided by x plus 4 and plus b divided by x minus 4 and then multiplied by dx. Okay, now we got already a, we got b, just substitute it here and then integrate individually. I'll continue it here, class, so that you can save space. Okay, so we have equal to the integral of 1 plus, so what is our a? Our a is equal to minus 15 over 8 divided by x plus 4, then plus, what is our b? Our b is 15 divided by 8 divided by x minus 4, and everything is multiplied by dx. Okay, then integrating both sides, integrating each term and using the concept of the the division of fractions, so we can rewrite this as integral of 1 times dx, that is dx, then plus minus, so we have minus 15 over 8. I'll just write it directly, class, as something like this. distribute dx in the denominator, which is x plus 4, then plus, so put the constant outside the integral sign, then multiplied by dx, so we have dx divided by x minus 4. Okay, so again we are going to use the formula from our previous lectures. We have integral of du over u is equal to ln u plus c. Okay, so we have to make use of this formula. All right, so from this result we can have our u here as x plus 4, then solving for du, so our du is equal to dx, and here in the third term we have u as x minus 4, then our du here is equal to dx. Okay, so this is now in the form of du over u. Our du, which is dx, our u is equal to x plus 4, so du over u, so we can apply this. Integral of du over u is equal to ln u plus c. Okay, so what's next? So we can now write this as the first term. Our first term here, integral of dx, is simply x. Okay, and how about the second term? So our second term, we have minus, so the constant, which is 15 over 8, then integral of du over u, which is ln of x plus 4, then plus, we have 15 over 8 times ln of x minus 4. Okay, and then we have plus c. Alright, then since we have this from our logarithmic rule, we have ln of m minus ln of n, so this is just equivalent to ln of m divided by n. So let's try to make use of this rule class in our result. Okay, so if you look at the result, we can still factor, we can factor the common, which is 15 over 8, and then we rearrange. So when we rearrange, so we can rewrite this as x, let's factor out the positive 15 over 8, so we use 15 plus 15 over 8. Okay, then rearranging, so this is the common, which is 15 over 8, and we have ln. So the result here is ln. We write this x minus 4 first, right? So x minus 4, because we factor out the positive, so this is positive here, so we put this one here on the others. We interchange the position, so we have, this is x minus 4, then this is minus ln of x plus 4. Okay, then plus c. Then applying the logarithmic rule, so we can rewrite our answer as x plus 15 over 8 times ln ln of x minus 4 divided by x plus 4, and then plus c. Okay, so this is our final answer. Okay, this is our final answer, class. So if during our examination, if you cannot find this one, I mean your result is only up to this one, and then there's nothing in the choices, something like this, so you have to try to use this rule, logarithmic rule, okay, and find out if you can get this answer. Okay, so that's all, and thank you very much, and hope to see you again in our next video. Bye.